Hello. In this session, we're going to discuss the changing landscape of the workforce and how this impacts on OSHA professionals. But before we start, we couldn't start a session on digital and tech without conducting a little survey. So please do grab your phones and scan the QR code on the screen to engage. In this session, we're going to discuss the rise of the collaborative robot, or the cobort. We'll explore exoskeletons, and we might even have an alien reference for those film fans. We will be understanding how the advancement in technology and connectivity is going to transform the future. And we're going to explore the question, are OHS practitioners ready for this transformation? Do we have the skills? Can we rely on our traditional OSHA methods when assessing the workplace of the future? So what does our future workspace look like? Well, we've already witnessed the change in jobs over the past 50 years, much more service-based. Along with these changes, we are balancing more unpredictable market developments, driven by global competition, economic instability, and eco-political influences. Globalization, free markets, strong focus on corporate social responsibility, on-demand workforces. Even in the past 2 years, we've seen changes to our work habits and place of work. There will be a greater knowledge gap between generations, from baby boomers to Gen Z, and we even have Generation Alpha that will appear in our workplace in the next few years. There will be an acceleration of digital transformation, which is the focus of our talk today. Behind the US and China, the UK is leading the high-tech sector with a market value of $1 trillion and over 3 million people working in leading UK tech companies. This growth is attributed to world-class research universities and ongoing investment to integrate tech into the industry. 85% of jobs that will be available in 2030 haven't even been invented yet. Therefore, the skills of future workers will change, not just IT and engineering skills, but the demand for coding and data science, specific skills as new technology emerges. So do our current OSHA skills compare with these future changes? Let's start by taking a quick look back at our industry. The first industrial revolution, known as Industry 1, began in the 18th century. It brought the steam power and mechanization of production. The use of steam power is already known, but this is when we start to use it for industrial purposes, and it transformed changes to mass production and transportation. As a good example of such machinery is the weaving loom, which was the first developed in 1784. Other machines that were invented during this period include the water wheel, more complex spinning wheels, and the steam engine. And as coal started to be used, further manufacturing processes developed. But it was dirty fuel. With an increased demand for production, there was more pressure on workers who often toiled in poor working conditions. The second industrial revolution began in the 19th century, using cleaner fuel of electricity and the introduction of the first assembly lines. Electrical machines were much more efficient, easier to operate and maintain. And also, they're very cost-effective, requiring fewer resources and human effort than the machines used during the first industrial revolution. You might think of Henry Ford, who took the idea of mass production into the automobile industry. The third industrial revolution began in the 70s in the 20th century through partial automation using programmable computers. This is the digital revolution with programmable logic controllers, a simple computer program that monitors the activity of an industrial process. So think about food production, where a portion of ingredients may be released from a silo and transported to a mixing bowl. This is why we call it partial automation, because only small parts of a production line were automated. It still required human interactions to program. A human programmer will give specific instructions to a robot. As an example, a fixed robot arm to pick up a specific object and place it in a pre-designed space. So from Industry 4, we then start to move from an analog world into a more modern digital world. Industrial Revolution 4, and it builds on the third generation through information and connectivity, where technology talks to other technology. Cyber physical production systems, smart factories in which production systems, components and people communicate, leading to production which is almost autonomous. Smart machines with the ability to trigger self-organizing actions. They can predict failures and carry out different maintenance processes autonomously. These machines will be able to predict and react to unexpected or abrupt changes in production. The other area you'll see in the fourth industrial revolution is the application of sustainability and environmental issues. So more eco-friendly to conserve natural resources, but it's also an opportunity to improve the efficiency of manufacturing processes and improve business productivity. The first two generations, they lasted about 100 years. The third ended in half the time. The fourth industrial revolution, well, it lasted 10 years. We're now living in Industry 5. And this term refers to the acceleration of integrated and shared workspaces alongside cobots or collaborative robots and smart machines. It will build on Industry 4 with enhanced connectivity. As technology, artificial intelligence and connectivity come together, it will bring new OSHA challenges. Consider how our application at OSHA has changed over these industrial revolutions, from physical safety to management and culture, human-centric safety, leadership and well-being. But now we're facing a tech change. I feel like I want to whisper quietly. The Industry 6 is already beginning to be defined. It's driven by the global economic crisis and the impact on supply chain and suppliers. It's a resilient building industry, which is hyper-connected and dynamic, and it's designed to bring sustainable solutions and growth to the UK and the global economy. But before 6 is here, let's take a step back into present day. As an OSHA practitioner working in a water processing and bottling plant 20 years ago, I remember with excitement the introduction of Robby the Robot, which didn't look too dissimilar to this picture. Robby had travelled from Italy and was installed to lift heavy 5-gallon water bottles and carefully and precisely place them into stillage cages. Robby was impressive. He was housed within his fixed guarding with various infrared and interlocking devices. And as a practitioner, my main objective was to keep away parts away from humans, which typically involve physical and procedural safeguards. But today we see robots released from the cages, roaming around workplaces with humans, making intelligent decisions. So our existing methodology for safeguarding may not be fit for purpose. So let's look at some of these new technologies. Automatic guided vehicles, AGV. They can navigate through shared spaces. Autonomous mobile robots, AMR. They can shut down in the presence of humans. So we are releasing the cobots from their anchored abode. Cobots can intelligently analyze and decide the correct task to perform. They're becoming more autonomous with the freedom to move on their own, use dexterity, sensing, memory capacity. And here's the key bit. With the ability to reflect and learn by means of algorithms, which allow them to correct behaviours and errors. They're learning. Cobots are not just limited to assembly lines, packaging and palletizing and manufacturing. A variety of industries recognise the benefits of cobots to increase productivity. As an example, within the construction industry, meet Hadrian X, nicknamed for his wall building ability. It is the first mobile robotic block laying machine. Hadrian X can lay 200 concrete blocks an hour. And whilst he's doing that, he can monitor and adjust to wind, vibration, and other environmental factors. There's no pre-lay track, which allows for flexibility. And Hadrian has the ability to build directly from CAD drawings. Cobots like Hadrian can build all sorts of structures and components. They can inspect, they can maintain, they can clean building fascias, they can demolish. Their applications and uses are endless. Autonomous vehicles, such as Volvo's HX2, it's an autonomous and electric load carrier, which is used by the construction industry worldwide. HS2 doesn't require a driver to operate the carrier. Instead, it leverages a digital logistics-driven control system to identify humans and other obstacles on the path. Other companies, such as Build Robotics, offer autonomous bulldozers and excavators to the construction site, which is incredible when you consider the changing dynamic landscape of a site. They use AI guidance frameworks to navigate. Large-scale 3D printing, painting drones, welding robots, self-driven vehicles, demolition robots, and the use of wearable tech have penetrated the construction industry. Now, this is a team of drones working together to produce art in Italy, and this mural took over 12 hours. But you can see how drones can be used to conduct tasks such as painting, inspections, underground drainage inspections. Aerial drones and ground-based robots can use to survey a construction site and gather various data. VR lets the site manager get a real feel of what the drones are seeing, but being able to experience it remotely, so they don't have to be on site to get an accurate assessment. You might be familiar with everyday wearable tech, so many of us will be wearing a smartwatch. It's a commonplace tech for monitoring our health, fitness, and well-being through tracking data. But wearable tech can also report OSHA data live, such as compliance monitoring, warn wearers of hazards such as moving vehicles nearby, take biometric readings such as heart rate, or indeed monitor the status of the wearer from air quality, noise, and heat. So as an example, to protect hard hat wearers from solar rays, heat sensors are built into the headwear. Smart glasses provide 3D mapping on a construction site to identify boundaries and hazard marking. Smart shoes can activate a Mayday alert. Glove scanners enable workers to scan products in production lines or in warehouses hands-free. So this is the film bit, okay. In 1986, Ripley, Sigourney Weaver, in Aliens fashioned the Hollywood power loader. Now, this is not a new concept, but it was the first robot exoskeleton to hit the silver screen. James Cameron termed the item as the future forklift, and he wasn't far wrong. Today, exoskeletons are not used for fending off the Zen Mall Queen, but can be used in a wide range of applications within industry. And here's an example. In 2020, Hampshire care workers tested a Japanese cobort exoskeleton worn around the waist to assist with moving objects and supporting people. The cobort identifies electrons from the user's brain connected to their muscles to stimulate movement. Caring for a person with complex needs may previously require two carers working together, but now in some instances can be delivered effectively by a single individual using a cobort. So when we consider the stretched staffing in the care sector and the predictions that we're all going to live longer, is this a solution to meet the care sector demands? Autonomous androids can do the rounds in care homes on their own, checking up on residents, bringing them their medicine or food, have pincers to open lifts, open doors, pick things up, equipped with UV lights to disinfect door handles and other services, built with sophisticated artificial intelligence that can alert nurses if a resident's posture looks to have changed, which might signal that they've had a fall. Such droids actually already exist, and they have been used in great success in Japan, Hong Kong, and Taiwan, and are looking to launch in the UK. And just while we're talking about healthcare industry, we've seen the introduction of AI apps such as Woebot, introduced by the NHS to support daily conversations and care about mental health. It is an excellent app if you've not used it before. Woebot, W-O-E-B-O-T. There's been numerous studies looking at the effectiveness of Woebot, including a study by Stanford University that reported a significant reduction in anxiety and depression for those using the app daily. So technology allows for a greater reach of people. It can support a struggling healthcare system with these tertiary offerings for prevention. South Korean car maker Hyundai have developed a new vest exoskeleton called VEX that can lift up to 50 kilograms over long distances. They've also got a chairless exoskeleton, a lower body exoskeleton that supports the wearer when they go into sitting position. Typically, these are examples of passive systems in the industry. So they're supporting joint movement and increased human capacity, usually for carrying weights and moving loads. But within the medical profession, power systems are being used in hospitals to support the rehabilitation of patients. Now, in this industry, you can see the power system looks bulky. The weight of a battery for mobile application has slowed down the mobility of powered exosuits, but eventually power exosuits will become more lightweight, cost-effective, and versatile, furthering human-robot collaboration. So as technology advances, so do AI and connectivity, and the merging of these disciplines will create a significant shift in the ability of cobots and the tasks that can be performed. Currently, we describe robots in terms of the input from humans, but imagine a cobot with artificial general intelligence. It will be able to understand, teach itself. So we'll go from this to this. A cobot being able to understand or learn intellectual tasks. We are building an artificial evolution. But we do have to consider the interface with humans. There's a whole discussion regarding how people feel working alongside cobots. These are pictures from a news article on the 18th of December 22, whereby construction workers are filmed kicking food delivery robots. People feel sorry for the machines, particularly when we're humanizing with faces and human features, and even assigning gender and names. So there's a much bigger conversation around how people feel about collaborative working spaces with cobots. And of course, people will also fear loss of jobs in such investment. The International Journal of Environmental Research and Public Health published some interesting articles around this, including techno-stress. It's a fear of one's inability to cope with technology that causes distress. So we talked a lot about technology in the workplace, but the biggest change will come from the intelligence and connectivity. So let's take a look at the way the internet has changed. Since the introduction of the internet in 1993, the way that we've used the internet has developed, and it will continue to change further in the future. Just like the industrial revolutions, we've also seen this in web revolutions. So take a look at the screen. The bottom left square, Web 1, this is the first revolution, and this is connecting information, read-only application at this stage. So consider it as an online library of content. The bottom right square, Web 2, connects people via read-write blogs. So applications like Facebook and Twitter thrive in this era. The top left-hand corner, Web 3, this is about knowledge and information becoming portal and personalized. We use immersive technology such as AR and VR. We see the beginning of the Metaverse. So let's explain a few terms here. VR, virtual reality. It's a stimulated experience that employs tracking around 3D near-eye display to give the user an immersive feel of a virtual world. And just as a side note here is like haptic technology or 3D touch. This refers to technology that can create an experience of touch by applying forces, vibration, or motion to the user. So imagine that actually VR becomes a lot more tactile. We're already seeing it in the gaming industry. So if you use a controller that vibrates when you're using a weapon or driving a car, being able to feel through touch and receive a reaction would be useful for engineering or medical training. Augmented reality, AR, is the interaction of digital information with the user's environment in real terms. It's overlaying in your real world. I'm sure that you've all turned yourself into a zombie or bunny when you're chatting with friends or family on the phone, so this is AR technology. VR and AR offer the advantage of removing many workers from hazardous environments, as they can be used, for example, to support maintenance tasks or for immersive training. AR can also provide contextual information on hidden hazards, so the presence of asbestos, electrical cables, or gas pipelines. So as much as VR and AR devices are becoming more and more developed, we may also recognise that there is a source of risk because of the distraction, information overload, disorientation, motion sickness, and eye strain. And of course, the Metaverse. So you've probably had the name, but what is it? The Metaverse is a bridge between the digital world and the physical world. Currently used for gaming, but also living your life in a digital existence, where perhaps you can buy and sell digital items such as clothing. There are many brands like Nike who are already trading. Also, it will allow digital interactions with humans as they are in a face-to-face setting, such as a music event, a social gathering, or even in a virtual classroom. There are approximately 160 companies building the virtual web, or Web3. They're all separate, but eventually they will link together. So think of it as lots of separate rooms that will eventually all become one building with connecting doors. Not convinced? Well, many tech companies, including Microsoft and Facebook, are already investing. Global spend on VR and AR is predicted to rise from 12 billion in 2020 to 72.8 billion in 2024. We expect the Metaverse to be a significant part of their everyday lives. Generation Z and millennials expected to spend close to 5 hours per day, but older generations are also expected to spend several hours in the Metaverse each day. But you might say, I'm not really into gaming, so how's this connected with a health and safety talk? Well, the gaming industry clearly are the forefront of the Metaverse, so it's no surprise that we connect those discussions with gaming. And while gaming remains a leading reason for accessing, consumers are increasingly looking for entertainment and other services. 1 in 5 Metaverse users have attended virtual live events such as a concert or film festival. And we're going to see more immersive experiences of training and learning to accelerate in this space. If you look already at the interest being expressed for this platform as a method of delivering learning, So Metaverse can not only provide education, but it can also provide the virtual classroom activity of networking. Since COVID, the term hybrid working has been seen as a solution to many employees, but some tech companies are building virtual offices in the metaverse. And although I feel a trickle of skepticism, I do remind myself it's been 2.5 years since I last walked into a physical office. The decision on adoption, opportunities, the investment, how the metaverse will shape our working lives will be driven by employees and consumers. And as a Generation Xer myself, I look to the younger generations of Gen Z and millennials who will shape this evolution. So let's step back to our web model. And the top right-hand corner is Web 4. So this is connecting intelligence, wireless connection between physical and virtual world, humans and computers in harmony. Internet of behaviours, that's a very interesting subject. You've already experienced this in a different setting. It understands, predicts and influences human behaviour through data collection and analysis. So consider how direct advertisement is intelligently tracking your internet activities you'll see sort of lots of adverts and sponsorship coming up, or entertainment providers such as Spotify. They can predict your likes and make suggested personalised playlists. So this technology is already transferring in industry using algorithms or computer-generated content. So as an example, if you think about e-learning courses that are being developed by designers or trainers, creating preset tasks or assignments, computers can generate content or tasks, and they can base it on the student's performance and progress. So computers are fed with knowledge about the subject matter and then given instructions on how to combine it to generate new material. This is known as adaptive learning algorithms. Students will be the architects of their learning and delivery methods. So this approach can be applied to tasks being performed by cobots. So if we go back to our model, and it's no surprise Web 5 has already been designed, there are endless possibilities, such as a website that can map the emotions of a person using facial recognition. Users can interact with the website, and the website would respond accordingly based on the emotions of a person. So could this help the care community or well-being of remote workers? Consider how these algorithms and artificial intelligence to the physical technology machines. And as we look into the future, imagine cobots that can learn and retrain themselves, understand tasks and activities in an autonomous state, making intelligent decisions based on learned algorithms, and knowledge that is constantly evolving, able to move freely in a shared workspace with humans. The HSC published research on the risk of human and robot interaction, but there's no specific guidelines on managing the risk. The European Agency for Safety and Health at Work has a campaign for 2023 to 25, which is raising the awareness about the impact of new digital technology on work and workplaces. Numerous research discusses the gap in existing risk management approaches, and this is mainly due to the complexity and versatility of cobots. In a traditional risk assessment, we would consider the obvious risks, such as collision or battery charging, etc. But what about over-reliance on a robot's ability when using exoskeleton, or psychosocial aspects of shared workspaces, human error in programming, or impact from cyber attacks? What new models could we use to dynamically assess this? What are the risks from a robot that can teach itself? Artificial intelligent robots making decisions. It's different to humans, and therefore the dynamic of risk changes. Therefore, does this create legal, regulatory, ethical, and privacy challenges and risks? Technology will also lead to new workspaces and new ways of working, which may generate new risks. As a recent example, we've recognised the increase in remote working has amplified feelings of isolation and mental health concerns for individuals. The OHS practitioners played a prominent role in promoting the dialogue of wellbeing organisations. So could a cobot contribute to promoting wellbeing remotely? Tech like big data and AI can have a huge positive impact on wellbeing, with large potential gains for environmental, sustainability, health and equality opportunities in particular. Cobots currently represent only 3% of all industrial robots sold, but they are projected to account for 34% of industrial robots sold by 2025. This is a market that is set to triple in size. Therefore, as Industry 5 and Web 4 collide, there will be a rapid and constant transformation of our workplace and how OSHA applies. OSHA has an important role to play within our vibrant future of leading the global OHS conversation while supporting technology progression. Investing in research, peer sharing knowledge, a platform for horizon scanning, identifying the potential mitigation controls of the future, upskilling our profession, having leaned in conversations at the design stage of new tech, and evaluating our current methodologies and risk management. The interaction between cobots, AI, and the connected world will be one of the most transformational factors in the modern world. We are on the cusp of the next era of human-machine partnership. And as the UK lead the tech revolution, the future poses an exciting opportunity for OHS practitioners to embrace the transformation, leverage technology, and reshape the scope of OSHA through the Industry 5 revolution, and continue to lead the world on OSHA best practice.